Yes, hello students from Losteke College all over Pulukwani and other campuses. Please watch this video, this memorandum, as we do it together. Okay, I'm sure it's gonna make you to get better grades. Yeah, this is Patrick Kamala. I'm a tutor and educator at Losteke College Pulukwani. Wherever you are watching our videos, please like and subscribe to get more notifications. Okay, so this is this year 2024 May June, and this is mathematics paper 1 memorandum. Please try the paper first, then use this video to mark yourself, because you're going to understand what is supposed to be done in paper 1 May June 2024, so that you can get a better marks in paper 1 November 2024. Okay, question 1. They say here that solve for x. Solve for x, that is 1.1.1. You see, we have here 3x squared plus 5x equals to 0. So we do here, because we have only two terms with a 0 this side, we can factor out the common factor here. In this case is the x, so we can say that our x, okay, then open brackets x, open brackets, left with the what? Left with the 3. You're saying you can take out x, then left with what? Left with 3x, and then plus 5 equals to 0. Now, because of the 0 here, we use what we call as the 0 product rule, which means either x equals to 0, okay, or the bracket is 0, that is 3x plus 5 equals to 0, which gives us x equals to I beg your pardon. Okay, you're saying we say either 3x plus 5 equals to 0 here. Okay, then if you take the 5 this side, it becomes negative. This so mean that our x equals to negative 5 over 3. Okay, so we have two answers here: x equals to 0, x equals to negative 5 over 3. Now, next question here, they say solve for x, that is 4x squared. Then we have plus 3x and then minus 5 equals to 0. So because they say the answer must be to two decimal places, it means that we must use the quadratic formula, which I think you guys are familiar with. So what is our a here? Our a is 4, our b is 3, and our c is negative 5. So because we have the a as 4, and then we have the b as positive 3, okay, then we have the c as negative 5. So we are going to use the quadratic formula. So it says that x equals to minus b, that will be minus 3, okay, then plus minus square root of b squared, that's going to be 3 squared, then minus 4ac, minus 4a, but our a is still a 4, okay, then our c is negative 5, okay. So I encourage you to put the brackets the way you see them here, so that you don't mess up. Okay, so divide by 2a. Now our a is 4, so if you get a calculator and punch in here, you're going to get 2x values. Just check them out. So you can either get a calculator there, punch in with me, then begin with the fraction button, and negative 3 plus square root, that is 3 squared, minus 4, brackets, again another 4, brackets, then another negative 5, because bracket divided by 2a, which is 8. So here it gives me 0.8 if I use a plus. So this is our first answer, 0.80, because they want two decimal places, 0.80. Then another one, if I use a minus here, I get negative 1.55, so negative 1.5 and 5 put here together. Next they say we have to solve this inequality here. Now what we have here, because it is inequality, we need to get the critical values by equating to 0. So we are going to solve x minus 1 bracket squared, okay. Then 9 is the same as saying 3 squared, so we can say 3 squared equals to 0. So mean that we can say that difference of two squares, we're gonna say x minus 1 and then plus 3, okay, into brackets. Also you can say that x minus 1 then minus 3 equals to 0. So giving us this one gives us x plus 2, okay, then into x minus 4, x minus 4 equals to 0. So what applicables which we have here? We have them as x equals to minus 2 and x equals to 4, okay. So the moment you get to critical values, then you can now come and draw your number line, okay, draw your number line here, draw your number line, and then put the critical values. So the critical values, we put them in from the smallest then to the biggest. Smallest here it is -2. Now look at our coefficient of x squared. It is if you see this going to be x squared with a coefficient of +1, so mean it's going to be having a smiling face. So the shape of the parabola to be drawn here would be like this, okay, like this. Now this parabola, it shows us y. It shows us the quadratic term, okay, equation, expression, okay. So now this line here we put the minimum or the smaller, then you put the bigger. Here the first one was -2, okay, -2 here, and then +4. Now this line is called y equals to 0. When you go above, then that's where the parabola is greater than 0, okay. When you go below, that's where our parabola is less than 0 or smaller than 0. So now check what the question wants. It says greater or equals to 0, which means that note this is x-axis, so looking for the x values on this x-axis where it is greater, which means it's above the x-axis, which means you're looking for this x values here, because you see this parabola here. Let me use a different color here. This parabola here, if I may use now red, you see this portion which I'm putting in red, what are the corresponding x values? They are these ones here, starting from 4 going this side, and you see that's when it is above the x-axis. Also this other side, if you check this other side of the parabola also, it is also above the x-axis. So these x values, they are the ones we are looking for in this question. So if you check properly here, you can see that here we have all the x values which are less or equals to -2 altogether, or the x values which are greater or equals to 4. Now this word all, it means union, meaning all these values of x combined with these values of x above 4. Yeah, that's our answer there. Next question here, then we have 5 to the power 2x, that's 1.1.4. 1.1.4. I need some space here. 1.1.4. If you check it out, we are also solving here, and what we have, we say that here we have 5 to the power 2x, 5 to the power 2x, yeah, to the power 2x, and then minus 5, okay, to the power x equals to 0. So because these are only two terms, we can write them as 5 to the power x, okay, and then again times 5 power x again, because x plus x to get to x, then minus 1 times 5 to the power x equals to 0. If you check here properly, you can see that the 5 power x is a common factor. It is a common factor here and here, which means you can take it outside the brackets. So when you do so, you're going to have the 5 to the power x, open brackets, left with 5 to the power x, then minus 1 equals to 0. The moment you have a 0, again you use the zero product rule. mean that either the 5 to the power x equals to 0, or the 5 power x minus 1 equals to 0, which gives us 5 equals to 1. And because this is 1, this is the base of 5. So what we do, we write it as 5 to the power x equals to 5 to the power 0, because we know that any number to the power 0 is 1. So in this case, our x becomes what? Becomes 0. Now this one here, because this is exponential function, it will never be equal to 0. So here, this is not applicable. So we don't continue from this one here. You stop it at this point. Hope we are together. Next question here, that is question 1.1.5. It says that x divided by root of 20 minus x equals to 1. So what do we do in this case? Now in such a scenario, we are going to cross multiply, and then later we are going to remove the square root by taking squares on both sides of the equation, and then we form the quadratic and solve it like that. Okay, so here we go. We are doing question 1.1.5. Question 1.1.5. Now, if I cross multiply, I'm going to have x equals to 1 times root of 20 minus x. Okay. So in this case, to remove the square root, because it's only one term now on the other side, I take squares. So it's going to be x squared, okay, equals to square root of 20 minus x bracket squared. So now here I have x squared this side. Now that other side, the square root cancels out with the square, and I'm left with the 20 minus x. Okay, so now it's gonna be x squared plus x. Okay, the 20 becomes a minus, so minus 20 equals to 0. So what are the factors here? We can see I have a bracket here with the x, another x here, and equals to 0. Now because I'm dealing with negative 20, look for two numbers, multiply, get negative 20, but when you add, you get positive 1. And because it's a negative 20 here, I'm going to have opposite signs. I'm going to have a positive sign and a negative sign. Now, here we have 5 and 4. Now, 5 times 4, we get 20. So, the 5 and the 4, 5 is bigger than the 4. So, because here the middle term is a positive, must be a plus 5. Okay, and then minus 4. So, we can say that here, either we have what now? We have either x equals to negative 5 or x equals to 4. But what we do here, whenever we have sides in the equation, we must check out to see which one satisfies the given equation. So for example, if we put in our negative 5 in here, let's check it out. We're going to have negative 5 on top, then divided by root of, now 20 minus 5, it makes 25. So you're going to have negative 5. Now square root of 25, it is 5, okay, which gives us negative 1. But this side, because we have positive 1, it means that our answer is not equal to negative 5. So what about with a 4? We can put a 4 here and see what happens. We put a 4. Now 20 minus 4 is 16, and square root of 16 is 4. So 4 divided by 4 gives us 1. So we take this answer here. Hope we are together. Don't forget always to check through which of the alternatives works best for the given question. Here we have the simultaneous, solve for x and y simultaneously. Now here what we need to know is that we identify which equation is linear and then use it to substitute in one which is not linear. So in this particular question, we can see that this other one is linear, this one is not linear. So what are we going to do? We can either say that our x equals to 9 minus y, or we can say that our y equals 9 minus x, and then later we do what? We substitute in the nonlinear and proceed to form the quadratic equation, which then we solve and then back substitute to get from equation 1. So here we go. Okay, so now in this case, what do we have from equation 1? We have x plus y equals to 9. We're doing question 1.2. Okay, we're doing 1.2, 1.2. Okay, so now in this case we said we can say y equals to 9 minus x. 9 minus x. Okay, so what about the nonlinear? We have 2x squared minus y squared equals to 7. So where you see y, we are going to put this one here, because this y is the same y which appears here. We are going to substitute by putting 9 minus x. So I'm going to say that now I have 2x squared minus open brackets 9 minus x bracket squared equals to 7. So I'm going to have 2x squared here, okay, minus, it's going to be 81 here, okay, then minus 18x, then plus x squared, okay, plus x squared here, and then close bracket equals to 7. So if I check properly here, I'm going to have 2x squared minus 81, then plus 18x, then minus x squared, and then minus 7 equals to 0. So what is, I'm going to be left with only a 1x squared, okay, then minus 81 minus 7 gives me minus 88. I get minus 88, okay, and then what about here? Then I say plus 18 plus 18x equals to 0. Now when I arrange it properly, it's going to be x squared, okay, plus 18x, and then minus 88 equals to 0. So do you have any factors? When we add, we get positive 18. When we multiply them, we get negative 88. Okay, we have those factors. What is 8 times 11? That's 88. But 8 and 11, when you add, you get 18. What are the factors here which we have? Let me check if we have those factors. For 88, but then they give us what? They give us that. So otherwise, let us use the quadratic formula. Okay, the quadratic formula here. So now our a is 1. We're gonna say x equals to minus b. Okay, but now minus what? Minus 18 plus or minus square root of b squared, which is still 18. Okay, 18, that's 18 squared minus 4ac. Now our a is 1, our c is negative 88. Okay, then divide by 2a, whereby our a is what? Our a is still 1. So we have x equals to what? Let's check it out here. Get your calculator. Negative 18 plus square root 18 squared minus 4ac. Our a is 1, our c is negative 88, then divided by 2, which gives us 4. So we have x equals to 4. Also, what about with the minus now? With the minus here, if I put a minus, I see that I get negative 22. negative 22. Okay, so don't forget our y from the first equation. It was y equals to 9 minus x. So when x is 4, it's going to be y equals to 9 minus 4, which gives y equals to 5. Okay, about this side here, I'm going to say y equals to 9 minus x, which is same as saying minus 22. Okay, so it becomes a positive. So I'm going to get y equals to 9 plus 22, which gives us 31. So this is what we have here. I hope we are together. I hope we are together. Okay. Okay, question 1.3. Given p equals to 1 minus x, that's our p, and the t equals to 1 plus a, then 1 plus a squared, 1 plus a power 4, then dot, 1 plus a power 5, 1, 2. Then they say we should find out p times t in terms of a. Now p times t in terms of a, we're going to say that our p times t equals to p, but the p is 1 minus a. Okay, what about times t? Now the t, we have 1 plus a, then multiplied by 1 plus a squared, multiplied by 1 plus a power 4, then multiplied by other terms which are also even powers, until you multiply by the last term, which they call 1 plus a the power 512. Now I want you to note this, that if I multiply these first terms, this one here, from here up the first two brackets, okay, what do I get? This is 1 minus a times 1 plus a. I can see it's a difference of 2 squares, so it's going to be 1 minus a squared. So now I have 1 minus a squared to be multiplied with the next one. So if you check this out, so I have 1 minus a squared times 1 plus a squared. Now again, 1 minus a squared times 1 plus a squared, it gives me, I can see it's a difference of 2 squares. But what does it give me? It gives me 1 minus a to the power 4, because I can say this is 1 power 4, it becomes 1 minus a squared times 1 plus a squared if I expand it. Now I am now multiplying this 1 minus a power 4 multiplied with 1 plus a to the power 4. Now I can see that again another difference of 2 squares is going to emerge from here. Okay, and in that case, if I simplify it, I'm going to get 1, okay, minus a to the power 8. Okay, so now because there are many products here, it means finally these ones are going to be collapsing until I get to the final one here, which in turn is going to give me 1 minus a, okay, to the, because you see this was 4, it became 8. If it was 2, it became 4, so it means it's going to be here 1 minus a to the power 2 multiplied by 512. Okay, so it's going to give me what here? It's going to be 1 minus a. What is 2 times 512? 2 times 512, 2 times 512, it gives me 1024. So this is our answer. It is 1024. Hope we are together. Next question, that is question 2. Question 2 here. They say consider the geometric series which is 4 plus 2 plus 1 plus a half, and so many. Does this series converge? Justify your answer. Now understand that for the series to converge, we must have the common ratio, which lies between what? Lies between -1 but less than 1. So from here, let's get our common ratio. We can see that our common ratio here is 2 out of 4, which gives us 1/2. Now indeed, because this half lies between -1 and 1, it means the series converges. So we say yes, the series converges. So what's the reason here? Because 1/2, which the common ratio lies between -1 but less than 1. That's our answer. Then they calculate the sum to infinity. That's 2.1.2. 2.1.2. How to find sum to infinity? Equals to a over 1 minus common ratio. So we're going to have it as a. Our a is the first term there, which is 4. So the common ratio was what? It was a half, so minus 1/2, which gives us 4, okay, divided by 1/2, which eventually gives us what? Gives us 8. So our sum to infinity is 8. Okay, now they give us 2.2, given that summation from p equals to k, okay, up to 10 of 3 to the power p minus 1 equals to 29520. This is a calculated value of k. Now summation means this is the sum of all the terms from k up to 10 and equals to this. So we need to find out the value of k. So mean that we are supposed to add all the terms from tk up to t10. Let's find out just now. So in this case, I'm gonna say that tk plus 1 plus tk plus 2 until the last term here, which is t10. Then I'm gonna solve. Now I see this is geometric, so like I said here, I'm going to have the first term by saying tk, okay, tk, then plus tk plus 1, then plus tk plus 2, okay, tk plus 2, and then plus so many times until the last one, which is t what? Which is t10, then must be equal to what? To 29520. So now in this case, if you look at what we have here and compare it with our nth term for the geometric, that's our tn. Our tn is given by what? It's given by the first term times common ratio power n minus 1. So if I compare here, this is p minus 1. I can see my common ratio is 3. So in this I'm gonna have my common ratio at 3 if I compare. Then if I check here, let me first find out my number of terms. Now the number of terms, please remember, is going by the upper limit minus lower limit plus 1. Okay, so in this case the upper limit is the 10, that is 10. Okay, what about lower limit? The lower is k, then plus 1. So what is 10 plus 1? Gives us 11, then minus k. So these are the number of terms, and because this is geometric, it means I'm going to use Sn equals to first term into 1. Okay, or I can substitute that common ratio power n minus 1 divided by common ratio minus 1. Okay, so they gave us this now. What is our first term? Our first term we just put in p equals to k here, so we're going to have 3. We're going to have what? We're going to have 3 to the power k minus 1. That's our a, open brackets. Then common ratio we set to 3 to the, now our n we set is 11 minus k This is 11 minus k. 11 minus, then minus 1 divided by 3 minus 1 equals to, they gave us 2 what? They gave us 2 9. This is 2 9. And then 520. 2 9 520. So I may open brackets here. I'm going to have 3 power k minus 1. Okay. Minus 1. And then plus what? Plus 11 minus k. Then 3 minus 1 is 2, so I'm going to say equals to 2. Okay, then also times this, I'm distributing. Again, minus 3 to the power k minus 1 equals to 2 times this number. That's going to be 2 times 2, 9. 2 times 2, 9. 520. What do I get? I get 590 and 40. I get 590. I get 5. I get 590. 590. And then I get 40. Okay. So from here, now if I see k minus k is going to cancel out. 10, 11 minus 1 is going to be 10. So it means I have 3 to the power 10. And then minus 3 to the power k minus 1 equals to 590. Okay. 590. Then 40. Okay. This one being a negative becomes positive that side. So I can say that 3 to the power 10, then minus 590, and then 40 equals to 3 to the power k minus 1. Now calculator, punch in that on there. If I check it here on my calculator, it gives me 9. It gives me 9 here equals to 3 to the power k minus 1. But what is 9? Someone saying 3 squared equals to 3 to the power k minus 1. So because I have the same base, it means that my 2 equals to k minus 1, which gives me k as what? Gives me k at 3. Okay, hope we are together. Let's proceed. Next question here. That is question 3. Question 3. Consider the quadratic pattern, number pattern. They gave us 3, 7, 12. They say show that this general term. So you need to find our Tn. Let's start out with this quadratic pattern here. We have 3. That is 3.1.1, 3.1.1. What do we have? We have 3 here. And then we have 7. Okay. Then we have 12. Okay. And so on. So what is 7 minus 3? We get 4. What is 12 minus 7? We get 5. We get 5 here. Okay. Then what is 5 minus 4? We get 1. Now if you remember our formulas, we know that our Tn for the quadratic equals to an squared plus bn then plus c. But in this case, where we know that our 2a is the second difference, so our 2a equals to 1. Then our 3a plus b is our first difference, which is this 4 in this case. And then our t1 is a plus b plus c, giving us the t1. So in this case, don't forget my 2a equals to 1, my 3a plus b equals to 4, and then my a plus b plus c equals to 3. So I'm going to solve them to find my expression for Tn. So here we go. So from here, my a equals to 1 over 2. After getting a, come and get my b here. Now that's 3a plus b should give us what? Should give us 4. But what is our a? Our a is a half, so 3 times a half, then plus b must give us 4. So our b equals to 4 minus 3 over 2, or you can say minus 1 comma 5, which gives us what? Which gives us b as 5 over 2. 5 over 2. After getting b, let's find out our c by using a plus b, by using a plus b plus c. equals to T1, which T1 in this case is 3. Okay, so our A, we know it is 1 over 2. Our B, we know it is 2 over 5. 5 over 2. 5 over 2. Then our C, we don't know, equals to 3. So if you add a half plus 2 comma 5, you get 3. So 3 plus C equal to 3, giving us our C as 0. So therefore our Tn is given by A, which is 1 over 2 n squared. What about our B? Our B is 5 over 2. Okay, 5 over 2. Then n, that's all, plus 0. So our C is 0. So basically that's what we wanted here. Hope we are together. Now they say here that what number must be added to Tn minus 1 so that Tn equals to 13527. I repeat, what number must be added to Tn minus 1 so that Tn equals to 13527. So what I'm gonna do, I'm gonna find my n by using Tn equals to 1 here. Then after getting my Tn, my n, I'm gonna say n minus 1, and I find Tn minus 1, then I subtract. Okay, so in this case, here we go. Let me put the red one here. I'm erasing this now. I don't want it. So in here, we have the Tn. We need to find the n we're talking about, that we can use it to find our Tn minus 1. So in this case, let's check it out now. So because we have the Tn given to us here, we can say that our Tn, which is given by n squared over 2, then plus 5n, okay, plus 5n divided by 2 equals to Tn, but they give us Tn as what? As 1, 3. This is 1, 3, okay, 5 to 7, 1, 3, 5 to 7. So multiply through by 2, you get n squared, okay, plus 5n, then minus 2 times this, ne? So what is 2 times 1, 3? 2 times 1, 3, 5 to 7. It gives me here 270, 5, 4. So minus 270, minus 270, and then 5, 4. 5 equals to 0. So this quadratic here, if I bring my formula again, my A is 1, my B is 5, and my C is on here. So minus B, so minus 5 here, plus or minus square root. Now my B is 5 again, 5 squared, minus 4AC, our A is 1, our C is negative 2, 270, 4, okay, divided by 2A, but our A is 1, so divided by 2. So now calculators, what do you get here? Calculators, here I get minus 5 plus square root 5 squared minus 4AC. Okay, my A is 1, my C is negative 270, 54 close bracket divided by 2. It gives me here 162. So my n is 162. Now because I have my n as 160, now to find Tn minus 1, I'm just gonna say Tn minus 1, the same as saying T of 161, because 162 minus 1 is 160, so going to be T 161. So T161, I'm going to come back and substitute here. Where I have n, I'm going to put 161, so I'm going to have it as 161, okay, 161 squared divided by 2, then plus 5 into 161 divided by 2. So what do I get here? So I'm going to say that this is 161 squared divided by 2, okay, then plus 5 into 161, okay, divided by 2 again, it gives me 13363. So I get here 133 Okay, now this is my Tn minus 1. I have the Tn here, it's my Tn here, and now I also have Tn minus 1. Because these are consecutive terms in my quadratic sequence, so what to add to this one to get this Tn must be the difference. So I'm going to subtract now to get my difference. It's going to be d equals to 13, okay, 1352 7 minus 13363. What do we get here? I'm going to say 13527 minus this here, it gives me 164. So the answer should be 164. Hope we are together. That's what must be added to Tn minus 1 so that our Tn becomes 13527. Okay, next question here. That's question 3.2.1. Okay. What must I do? Let me go for this now. 3.2.1. What do they want us to do? 3.2.1. Given arithmetic sequence with the t1 equals to 8, t2 is 11, calculate the value of n if t4 equals to 41, tn equals to 41. So now being arithmetic, guys, what is our tn? General formula. What do we know about that? Being arithmetic, our tn is given by first term a plus n minus 1 times d. Okay, here. So in this case, they gave us t1. So our t1, we see it is a, which is same as what? With the same as 8. They gave us 8 here. Then our t2, it is 11. So t2 is 11. Okay, and then I need to find my common difference. So my d given by t2 minus t1, it gives me what? What's 11 minus 8? It gives me 3. Okay, so my tn is given by a plus n minus 1 times d with arithmetic, and then they said I must equate to what? To 41 to get my value of n. So equals to 41. Okay, so in this case our a, we saw that a is 8. Okay, n minus 1. What about our common difference, which we saw it is 3? Okay, equals to 41. So here what do we do? Now 41 minus 8 divided by 3, what do you get? 41 minus 8 divided by 3, it gives us 11. So I'm gonna have my n minus 1 equals to 11, which gives my n as 12. So my n there is 12 for this first part of the question. Then they say here that a new arithmetic sequence P is formed using the term position and the term value of the given arithmetic sequence. I repeat, they say here that they say that what? They say here that a new arithmetic sequence P is formed using the term position and the term value of the given arithmetic sequence, this one here, which we have done above here. Then they say for the new sequence, P8 is 1, they say P11 is 2, and so forth. Write down the value of P41. Okay. Now, because they're saying that this is very important here, please, using the term position, okay, and the term value of the given arithmetic sequence. And for example, they have said that our P8 equals to what? P8 equals to 1. Then our P11 equals to what? P11 equals to 2. Now if you take what we had here, this was T12, right? Now because we have from previous one that our T12 equals to 41, okay, which means here P41 equals to 12. That's our answer. Because P8 is 1. That was our T1. Are we together? Then P11 is 2. That was our what? Our T2. Okay, so then here, which means our P4 is going to be what? It's going to be 12. Now let's say calculate the value of the first term of the new arithmetic sequence. So to get our first term of the new arithmetic sequence, in this case, what do we do? What do we do? We know the P8 is 1, P11 is 2. Okay, so you just have to solve them simultaneously. So we know any arithmetic sequence, our Tn, okay, our Tn equals to A plus N minus 1 times D. Okay, so in this case, our P8 is what? Our P8 is 1. So you're going to say that our first term A, which we are looking for, plus what is 8 minus 1? It's going to be 7. Okay, 7D. Then they said equals to what? Equals to 1. Okay, that's the first equation there. What I can say that I can say that is it. I also have here P11 is 2, so I'm going to have A. Now, what is 11 minus 1? That's going to be 10. It's going to be 10D here. Equals to what? Equals to 2. So these two equations, okay. When I say equation 2 minus 1, what is A minus A? I get 0. What's 10 minus 7? I'm going to get 3D here. So 3D equals to 1 because 2 minus 1 is 1. So my D equals to what? Equals to a third. But they were asking for the A. So A equals to 1 minus 7D. 1 minus 7D. So I'm going to have 1 minus 7. What's our common difference? It is a third, which gives us 1 minus 7 over 3. What do we get? 1 minus 7 over 3. It gives us here negative 4 over 3. So our first term is negative 4 over 3. Here together. Question 4. Question 4 is what we're looking for now. Question 4. Okay, now question 4, it says that it says here, given g of x equals 1 over x minus 1 plus 2, write down the equation of the asymptotes of g. Okay, and they draw the graph. Okay, now we know this is a hyperbola, whereby the asymptotes we have, we just equate this one to 0, this x minus 1. So if I say x minus 1 equals to 0, it gives me x equals to 1 as my vertical asymptote. Okay, then horizontal, we just take the y, whatever is here. That means y equals to what? Y equals to positive 2 is my horizontal asymptote. That is it. So you have these two answers here. Then they say here, draw a graph of g indicating any intercepts with the axis and the asymptote. So because I have the asymptotes, let me find the intercepts now. Because I have y equals to 1 over x minus 1 plus 2. Now what happens that my x-intercept, y is 0. I'm going to put 0 here. 0 equals to 1 over x minus 1, then plus 2. So the 2 becomes a negative to this side. Okay, equals 1 over x minus 1. So mean that I'm going to say that in this case, negative 2, or I can say x minus 1 equals to 1 over negative 2. Okay, over negative 2. So meaning my x equals to what? My x equals to positive 1, right, minus a half, which gives us what? Which gives us x equals to 1 over 2. So the intercept becomes what? A half is to 0. Okay. Then my other value here. Now when my x is 0, what's going to be my y here? I'm going to have y equals to 1 over negative, what's going to be negative 1 here? Negative 1 plus 2, it gives me 1. So it means that what's my coordinate there? The 0 is 1. Now that I have the intercepts and the asymptotes, I can draw the graph here. Okay. So here we go. It said draw the graph. That is 4.2. 4.2. We need the graph here. Okay, let's do our axis. We have here. Now, if they say that draw the graph, they want to draw something which is meaningful but not exactly accurate. That's why we call it a sketch. That's why we call it a sketch. So here we have the x and y axis. Okay. So this is our y-axis here. This is our x here. Now always beginning with the asymptotes, we have x equals to 1. This is 0 here. Okay. So x equals 1 must be somewhere here. So I'm going to do it here. My x equals to 1. I'm going to make it dotted so that it doesn't confuse us with the y-axis. So this is positive 1. Okay. And this is x equals to 1. Okay. Then we have the other asymptote, which is y equals to positive 2. Now I'm going to put it here. Y equals positive 2. Okay, so this y equals to positive 2. The other asymptote is horizontal now in this case. So this is 2 here. So this is y equals to 2. This was x equals to 1. Okay. Now, because my value of a is a positive, look here. This one is a positive. It means my orientation is going to be in the first and the third quadrant. So now if you look at my intercept, I've got 0 is to 1, then half is to 0. So now what I have to do, I know it's supposed to be in this quadrant, the first and the third. Né? So I just draw like this. Just draw it like this. Come here, draw. Don't touch the asymptotes, okay? But turn towards them. So that's my graph there. Then like this one here. Okay. Then now after drawing, now I put the values now. That's why they say a sketch. So I have this one here and this one here. They said 1 it is what? 0 is to 1. So I have 1 here. Then a half, it's going to be 1 over 2 here. That's my 1 over 2. Yeah, that is it, guys. That's my thing there. Alright, next what must we do? Say determine the values of x when the g of x is greater than 0. Now this is our g of x here. Where is it greater than 0? Where is it greater than 0? Now this line here is called y, or you can call it g equals to 0. G of x equals to 0. Okay. Now above 0 it means must be above the x-axis. So it means this is the portion that is above 0. Okay. This one here. So it means all the x values, okay, all the x values which are less than a half, that's what I'm looking for. All, if I check here now, after a half, this one goes down. So it means all values bigger than 1 now. It's going to be all x values which are greater than 1. I can see my portion is above here. It sits above this line. That means bigger than 0. So these are the answers which I'm looking for. Hope we are together. Next question here. What does it say? They say that determine the equation of the axis of symmetry of G which has a negative gradient. Now negative gradient, it means we're going to use negative 1. Okay. Understand that in this case we have got two lines of symmetry. One with a negative gradient, that is 4.4. Okay. Get some space here. So in this case, please look at this. Don't forget this, students. Looking for the line with a negative gradient with a line of symmetry, you must always use, you can use y equals to mx plus c, but our aim must be negative 1. So we're going to use y equals to negative 1 x plus c. Now what you see here as our x, that's what we have in our denominator. That is what we see here as x minus 1. So we're going to say negative 1, open brackets, x minus 1. Then what you see here as to get our c, we say plus this 2 here, so we say plus 2. We say plus 2. So we're going to have negative 1x, then plus 1 plus 2, okay, which gives us our answer as y equals negative 1x plus 3. That's our answer for 4.4. Hope we are together. Let us proceed. Next question. Question 5 here. That in the diagram, the graphs of f of x equals to log of base a of x and g are drawn. Graph G is the reflection of f in the line y equals to x, and the graph f passes through the point 4:2. Q is the x-intercept of f, and R is the y-intercept of G. They said this one is a reflection of one of the other. In the line what? In which line is that? The line y equals to x. I'll begin by drawing it here. So don't forget to use it. Now this line y equals to x, it goes like this. Okay. And the line y equals to x. This one here is supposed to be passing through this. It must pass through that one there. Okay, so now in that case must pass through this one. Okay. Now let us get what they want us to get here. They say write down the coordinates of p prime, the image of p. Now if this is the line y equals to x, which is supposed to be passing through the origin here, just did pass there, it's supposed to pass here. So this, if this is p, our p prime is somewhere here. Okay, p prime somewhere here, and this is a line which you call y equals to x. So when you do reflect it here, this p, okay, we swap x and y, so it becomes 2:4. Becomes what? 2:4. So here our answer is going to be p prime 2:4. Because we said y equals to x, we swap the x and y here to get our image. Then show that a equals to 2. Show that a equals to 2. Now our f of x, they gave us our f of x, that is 5.2. They said that our f of x, which I can call y, equals to log base a of x. Now as you can see, it's passing through point P. Now point P is what? It is 4:2. So to get my a, I'm going to substitute to get my a. My y here is the 2. I'm going to say 2 equals to log base a. What about x? X is 4. Now, but I'm looking for this a here. I must change from logarithmic to exponential. One thing for you to remember is that always the base is the same. So here our base is a. So I'm going to say a power 2 equals to 4. A to the power 2 equals to 4. So how to get my a from here? I'm going to square root, square root, which means our a equals to 2. Our a equals to 2 as they wanted. Okay, next question. Write down the equation of g in the form of y equals to that. Now our g is the inverse of f in this line y equals to x, and our f is logarithmic. And from our theory, we know that the inverse of logarithmic is exponential and vice versa. So because our f of x, okay, is logarithmic, which is log base 2 of x, okay, base 2 of x. So to get our f inverse, which in this case is the g of x, we just change it to exponential, okay. It's going to be now 2 to the power x. That's our answer. So we say y equals to 2 power x, because the log, its inverse is exponential function. Next question. Don't forget that the base must be the same, okay. then they say here that T is a point on F in the first quadrant where TR is parallel to the x-axis. Calculate the area of triangle RTP prime. Okay, they're saying that T is a point on F in the first quadrant. Né? Okay, what must we calculate? Area of the triangle, né? Let's find out here. So, okay, that's what it has to do here. They said that T is a point on F in the first quadrant where TR so must be parallel to what? The x-axis. So it means it must be passing through R and parallel to the x-axis, né? Because they're saying so here it must be what? Parallel to the x-axis, né? So I must begin from this area here to go and find my T. Okay. So it must be like this now, somewhere here. But they're saying parallel, né? It's my T here. So that's my point T. My point T here. And my R is there, okay, from my G. Alright, so and then they say P prime, so I must join it to P prime. So P prime is up there. Let me join it here. Up here. Okay. Alright, and then I must form a triangle, né? Triangle RTP prime. So from R here to P prime. Alright, so what must we do? Now because they are parallel, this must be parallel to this one here. Okay. So what do I need to find out? The area. So because I have R as the x-intercept for my exponential function, that means my exponential y equals to 2 power x, okay? And I know here x is 0, it's going to be y equals 2 power 0, which gives me 1. So this is 1 here. So being a 1 here will be the same y value for this point t, okay? So I don't know the x here, but I know the y. So to get my x here, I'm going to use the logarithmic now. They said my g of x, which was my f of x is y equals to log base 2 of x. But now I know the y as 1. I'm going to say 1 here equals to log base 2. I'm looking for this x here, so I'm going to say 2 power 1 equals to x. X equals to what? X equals to 2 to the power 1. So here it means it's going to be 2 is to 1. That's my coordinate here. Then my p here, I know I should be having the same one. I have the same x value and I know the y is 4. Okay, I'm looking for the area. So now because they have the same x value, this must be 90 degrees. Okay, I need the area. So from R to T, my distance is 2. Then from T to P, what is 4 minus 1? It is 3. So I can find my area by saying that area equals to a half times base times height, which gives me 1 over 2. The base is what? The base is 2. What about the height? It is 3. So it gives me 3 units squared. 3 units squared. That's my area which they want for the triangle RTP prime. Hope we get together. Let us move on. Next question here. That is question 6. Question 6 says here that the graphs of f equals to x squared minus 2x minus 3 and the g of x equals to mx plus c are drawn below. D and E are the x-intercepts and P is the y-intercept of f. The turning point of f is t 1 is to minus 4. The graphs of the f and g intersect at P and E. So they intersect at P and E. This E and P, okay? Write down the range of f. Now the range of this parabola is the set of y values for which the function is defined. So our t, they gave us what? They gave us 1 is to negative 4. Meaning that this point here is going to be what? Negative 4. So as you can see that our parabola is going up starting from -4, and this the y-axis. So it means that our range is going to be all the y values which are greater or equals to -4. That's our range. The coordinates of D and E. Now D and E, we see the x-intercepts. What happens at x-intercept, guys? That is 6.2. At x-intercept, we know that y equals to 0. Ne? We know y equals to what? Y equals to 0 at x-intercept. So I'm going to solve now. I'm going to solve my x squared, okay, minus 2x minus 3 equals to 0. So I'm going to have, what are the factors here? I have x minus 3, then x plus 1 equals to 0, which gives me x equals to 3, and also x equals -1. So if I check here, the positive must be for E. So here must be the 3. This must be the -1 here. But because they want coordinates, I'm going to say that my E is what? 3 is to 0. What about my D? -1 is to 0. Then the equation of G. Now this G is passing through, you're also passing through this point P. So point P is the y-intercept for this parabola as well, which I see from here, if I put 0 here, it's going to be 0 squared minus 0 minus 3. It's going to be -3 here. So P is 0 is to -3. 0 is to -3, okay. And now the G of x is passing through these points here. We're doing 6.3 now, 6.3. So we have the coordinates P, which is 0 is to -3, okay. Also passing through E, which is what? Which is 3 is to 0, okay. So I need to find my gradient because this is a straight line here. So my m equals to change in y over change in x, going to be now 0 minus -3 divided by 3 minus 0, which gives me +1. Okay, and then passing this intercept here, so my equation, I can say my c is what? My c is -3 here. This -3, né? My c is -3, and so what is my g of x? G of x equals to mx, but my m is 1, it's going to be now 1x, then -3. That's my answer there for 6.3. Then 6.4, they said that write down the values of x for which f of x minus g of x is bigger than 0. So in this case, if I want to do this one here, I have to rewrite it properly. That's 6.4. I'm going to write it as f of x. Instead of saying minus, I'm going to say is greater than what? Than g of x. So now if we say that f of x is greater than g of x, this statement means to us that our function f is what? Is above g. So we're going to check the x values where the function f is above g. That's all we need. Okay. So if we check here, let me start from here. You see at point P going to the left here, which one is above? F is above, then G is below. We're saying F is above G here, which means that's what I'm looking for. So I have all the x values less than 0. That's one of my answers. So I have what? X less than 0, because at P my x is 0. Then check here now. Between 0 and 3, which one is above? G is above, then F is below. But we want F must be above G, so I don't want this interval. Now check after E, after 3, which one is above? F is above, G is below. So it means I have all X bigger than 3. Yeah, that's the answer here. Now they say here that determine the maximum vertical distance between h and g if h of x equals -f of x for the interval from -3, -2 to 3. -2 somewhere here to 3. So now looking for the vertical distance between h and g. Okay, where they say if h of x equals to -f of x. Now now to get our h of x, actually we are reflecting f of x along the what? Along the x-axis, and then in this particular case, let us get our h of x first. So our h of x, I need some space here. I need some space here. Need some space here. Here. All right. Now from here, I want the vertical distance. Now because I'm dealing with the functions, please understand that our distance in function we're going to subtract the one on top. So let me first find my h of x. So h of x equals to -f of x. But what is my f of x? That's what I have here. As they give us what? F of x. Let's check here. They give me my f of x. They give us x squared minus 2x minus 3. So we say here x squared minus what? We have x squared minus 2x, then minus 3. Okay, which gives us negative x squared plus 2x plus 3. Now that's our h of x. If I may sketch h of x, actually it would be like this one here. Come like this, and then also pass here like this. Now I want the distance between h of x and then this g of x. This is straight line here. So if I may draw one of the distances here for you to see, check here, like from here up to here. Okay, this distance from here up to here is what we're looking for, but we want to see which one is the maximum distance. Okay, so this is our g of x. Okay, so now to get our distance d, let me call it capital D here. I'm going to subtract the h of x minus g of x. Okay, so our distance in terms of x equals to h of x minus g of x. Okay, so we're going to say here negative x squared, then plus 2x, then plus 3, okay, minus x, then this one becomes a plus, plus 3. So like terms here, we're going to have negative x squared, okay. Now 2 minus going to be then plus x here, then plus 6, okay. That's our distance in terms of x. Now to maximize it, we can differentiate. We can differentiate and then equate to 0. Okay, then equate to 0. So differentiate here. What do we get for this? Differentiate this. With respect to x, we're going to have d giving us here negative 2x and then plus 1. But I must equate to 0, ne? Okay, so I have my x as what? As 1 over 2. So to get my distance now, which I'm looking for, it's going to be distance d equals to d expression. I'm going to put a half now, ne? So it's going to be now, I'm going to say negative here, then a half, that's 1 over 2 squared, because of negative x squared, then plus a half, okay, then plus 6, okay. All right, so what do we have here? Now negative a half squared is going to be negative a quarter, then half minus a quarter is going to be a quarter, quarter plus 6 will be 6,25. So our answer will be 6,25 here. It's going to be 6,25 units. That's what we have there. Next on the Q, let's check it out. They say that now, given k of xc equals to gx minus n, determine n if k is a tangent to f. Determine n if k is what? A tangent to f here. Now, our g of x is what we have as this straight line here. This line here, okay? Because they say minus n, it must be a vertical shift until it touches the function at only one point, okay? So what do we do? What now? That n must be a vertical shift. So if I may draw a tangent, which is part of this line here, to look something like this. Let me try to sketch it here. That tangent, let me draw it in red color now. It would be like this. Okay, must be part of this one. So I must say that in this case, that tangent could be something like this. Okay, this line here, but must be parallel to that other. Okay, so this tangent is somewhere here touching at only one point. That's why it's called a tangent. Ne? Okay, now this tangent we're talking about here, as you can see, it must be parallel to this line here, because it was just what? Just a vertical shift, a downward shift. Ne? So the distance between the two lines here is our n, which we are looking for. Okay, so here we go. Now, being parallel, we have the same gradient, right? We have the same what? So our g of x, we know our g of x was given by what? Was given by x minus 3. Okay, x, that's 1x minus 3. So in this case, our gradient for the tangent is 1. So if this is our tangent here, our m tangent is what? Our m tangent is 1 from our equation here. Then now, because I have this function here, f of x, this gradient, which is 1, should be the same as the gradient function for the given function. I repeat, this gradient, which is 1, should be equated to the gradient function of the f. So I must differentiate my function. So they said that our f of x was what again? Let's check it again. Our f of x, they gave us x squared minus 2x minus 3. Okay, I have what? I have x squared minus 2x minus 3. I have what? I have x squared minus 2x minus 3. Now differentiate it. What do we get here? We're going to get 2x minus 2. Now this 2x minus 2, being a derivative function, must be equal to this one here. So I can get my x value with the point of contact. So I'm going to say my 2x minus 2 equals to 1. So I'm going to have my x equals to 3 over 2. Now to get my point of contact, I'm going to put the 3 over 2 into the original function here. So if I do so, I'm going to have my f as do I need f anyway? I need g actually, not f. I need g because I have the x. I need this g here. Yes, I need this the y at g, the y at this point here. I need the y at that point there. So what do I do then? If I put it there, I'm gonna have, remember it is our what? It is our y value for the point of contact. Yes, for the point of contact here. So I put 3 over 2. I'm gonna put 3 over 2 here. So f 3 over 2. Put it here. What is our function? It is x squared. It's gonna be now 3 over 2. 3 over 2 squared. Okay. Then minus 2x, that's minus 2. 3 over 2. And then minus 3. Which answer do we get here? We're going to have it as let's check it here. That is 1,5 squared minus 3 minus, yes, minus 3, also minus 3, which gives us negative 3,75. So we have negative 3,75, negative 3,75. Now this is my y for the tangent at that point, né? Okay, because it must be the same as that for the function. Now what about the y for g of x, which was translated downwards? I know my g of x, né? It is x minus 3, but my x at this point must be what? Must be the same as this one here, which is the 3 over 2. So for g of x, I'm going to put in 3 over 2 as well. G of 3 of 2, I know my g of x is what? My g of x is x minus 3, right? Okay. Now I'm going to find g of 3 over 2, which gives me 3 over 2 minus what? Minus 3, giving me negative what? Negative 1,5. Negative what? Negative 1,5. Yes, negative, oh, you can say negative 3 over 2. Negative 1,5 here. But I'm looking for the what? Let's check it again. They say looking for the value of n. So now this time, because I have my function, I have my gradient, and I have my values, so I can find my what? I can find my what? Okay, to make it very clear, let me show it properly here. Let me see what I'm talking about here. You see, this g of x was shifted. Okay, let me use green now. It was shifted from somewhere here altogether up to somewhere here. So that's my n, which I'm looking for. Okay. So in this case, from here up to this point here, I am going to subtract the g of 3 over what? Of 3 of 2. Okay. I mean the y value here, which is for g, and then the y value here, which is for the tangent altogether. So that's why I have, I'm the one for the g, as you have seen here. I have what? I have the y for the g, I have negative what? I have negative 1 over 5. Negative 1,5. Then the y for the tangent is negative 3,75. So if I subtract the 2, that must give my n. So n, the shift is going to be the negative 1,5, which is the same as negative 3 over 2, minus the one which is negative 3, okay, negative 3,75. So it will give me negative 1,5, then becomes the plus, plus 3,75. So what's our answer here gonna be? It's gonna be 2,25. 2,25. Hope we are together. That's our n. Okay, next question here. That is the question 7. Question 7 here. Question 7 here. What does it say? They say here that 6 years ago, Tabo bought a phone at 1300. The value of the phone depreciated annually according to the balance method. The value of the phone is now this much. Calculate the annual rate of depreciation. So it is depreciating, and using reducing balance method, so we know the initial price and even after depreciation. So we want to get the what? The rate of depreciation. So that's question 7.1. What does the formula say? That our amount A equals to P into 1 minus I, the power n, since we're using reducing balance. Now this A is the final amount. Let's find that's going to be 8 what? That's our 833 here. Then 7,75, okay. And then equals to P, the original amount of the new phone, was 13,000, okay. and then into 1. Now our rate is going to be now rate divided by what? By 100, okay? And then to the power how many years? They said 6 years ago. That's going to be power 6 here, okay? Because they said per annum, okay, 6 years ago. So what do we do here? Now we're going to divide here by 13,000. What do you get? Divide for me, that one there. That divide for me, that is 833,7,75 divided by 13,000. It gives me here 0.64, okay, 0.641, 0.641, 0.64137, okay, 0.641 times 37 equals to 1 minus rate out of 100. Now to remove the 6 here, I find the 6th root. I find the 6th root. So what do you get there? Shift 6th root of this answer here. It gives me 0.92864. I have what here? 0.9282864 equals to 1 minus rate over 100. So I'm gonna say the rate here out of 100 equals to 1 minus this. So what's 1 minus that answer? It gives me here 0.07135, okay? 0.07135, okay? So in this case, my rate times 100 now, so times 100, it becomes here 7.14%. So that's our rate of depreciation, 7.14% on the reducing balance method. Question 7.2. They say here that Eric and Tandy need to save 80,000 each to go on a holiday at the end of December 2027. Tandy decides that she will start saving at the end of January 2025. Then she will make 36 monthly deposits into a savings account that pays interest of 8.6% per annum compounded monthly. The deposit will be made at the end of each month. Then they say Eric calculates that if he makes 48 deposits of this month, starting at the end of January 2024, he will have enough money to go on holiday. He will make his deposit into a savings account at the end of each month. The savings account pays interest of 8.6% per annum compounded monthly. So we have the same interest rate. Then they say here calculate the difference between the total amount that Eric and Tandy will deposit into their respective savings accounts over the given period. I repeat, we have two people here. Eric and Tandy need to save 80,000 each to go on a holiday at the end of December 2024. Then they say Tandy decides that she will start saving at the end of January 2025. She will make 36 monthly deposits into a savings account that pays interest at 8.6% per annum compounded monthly. The deposit will be made at the end of each month, okay? And then Eric calculates that if he makes 48 deposits of this money starting at the end of January 2024, then he will have enough money to go to the holiday. He will make his deposit into a savings account at the end of each month. So the savings account pays interest of 8.6% per annum compounded monthly. So they say here, calculate the difference between the total amount that Eric and Tan will deposit into their respective savings accounts over the given period. Now these guys, they're depositing money every month and they're getting the money after a certain period of time. So because they're going to be depositing money equally, equal annuities, and they get after a period of time, it means that in this case, we are going to use what we call as what? The future value formula. Because the future value formula is used or is applied when you're depositing money to get a lump sum at the end of after paying all the installments for a given period of time. So now the question here says calculate the difference So I'm gonna get the money accumulated by the first person, that is Tandy, the money by Tandy, okay. Then also get the money paid by Eric altogether. Then I subtract the two amounts, okay. Let me first get the money paid by Tandy. So he pays this much, but I don't know how much Tandy pays every month, but I know she wants to get this money, so I must use it to first get my monthly payment. So future value is FV equals to X, open brackets, 1 plus I to the power N minus 1 divided by what? Divided by I. So here she wants to get how much? 80,000 rands equals to X, okay, open brackets here, 1 plus I. The rate was given to us as what? As 8.6%, okay, divided by 12 because we are compounding per annum. They said she makes how many? They said 36 deposits, so it's going to be power 36 here, and then minus 1, okay, then divided by still 8.6%, okay, divided by 12. So I can get my X from here by saying this 80,000 times denominator, then divided by the numerator. It gives me my X. So calculators, help me out. You can say the 80,000, okay, was denominator, which is the 8.6%, okay, out of 12, and then divided by the numerator, that is open bracket, 1 plus 8.6%, okay, out of 12, okay, out of 8.6% out of 12, okay, then power how many months? Deposit payments, power 36, and then it's minus 1. Here I get 1955.78. So Tandy every month end she pops out how much? She pops out 1955.78. Now how much does Tandy pay at the end of this period? Let us find out. So amount by Tandy, I'm gonna call it 80. It's gonna be this money, that's 1955.78. Because they said 36 months, so times 36. How much is that? Let's check it out. So times 36 times 36, it gives me here 70408. I get here 70408.02. Now amount for this other guy, Eric, I'm going to use R. They said that Eric here paid how much? They said that Eric makes this 48 payments. That's going to be 48. How much does he pay? This money here, which is 1.4, 1,402 rands, 31. So how much is that? Let's find out. So this money times 48. So I'm going to say 48 times 1,402.31. I get 7. I get 6 1. I get 6 7. And then 310. Okay, then 8. So the question is the difference, because this question said calculate the difference between their total amounts. Okay, so in this case, the difference is going to be given by what? The money for amount for Tandy minus amount for Eric. Okay, so get this money, the 70 for 0 minus this one here. What do we get here? Let's find out. So that is the 70408. Okay, comma 02 minus that money there. It gives us here 3097. So that's the difference in their amount. It is 30. It is 3097, 14. Okay, this is 9 here. Hope we are together. I hope we are together, people. Now, next question here says that Lesivana was going to list a loan here. Rate of the interest of the loan is 9% per annum compounded monthly. Lesivana will make a monthly payment of this much, starting exactly 4 months after the loan was granted. How many payments will Lesivana make to settle the loan? I repeat, they said that Lesivana, okay, was granted a loan of that much, and then they said that the rate of interest for the loan is what? It is 9% per annum and compounded monthly. Okay. Then they said that Lesivana will make monthly payments of 5,500 starting exactly 4 months after the loan was granted. Okay. Then they say how many payments will Lesivana make to settle the loan? Now, being a loan, we use the PV, the present value formula. Now, any loan, if the rate is compounded monthly, they give you a grace of 1 month before you start making the payment. However, in this particular case for Lesivana, because he started making payment after 4 months, it means that this loan was growing because the 4 months, only 1 month is used for payment. The other 3 months, the money was growing. So you're going to say, find out the new loan after 3 months because you're going to, if you say 4 minus 1, you get 3. So let us find out the new loan, that's amount, okay, new loan. After growing this money for the next 3 months, it's going to be 2, 5, 0, open brackets, 1 plus I. The rate is still 9%, okay, 9%, and it is what? It is compounded monthly. Okay, so I better do like this. I better say 9%, divide by 12. Now, for how many months was that? It was 3 because he did not pay for the 4 months, so we only take out 1 month, then the 3, and the money must grow. Okay, so here, how much is our money gonna be? That is 22530 zeros, okay, 22530 zeros times open bracket here, 1 plus our rate which is 9%, okay, divided by 12 because we're compounding monthly, then the power 3 months where he did not pay. So by the time he started paying, the money was 230,100. It was what? It is 230,100. Then comma 56. So this is the money. This is a loan to be settled. The question says how many payments will he make? We know the monthly payment is this much. That's 5.5. So now PV value here said that the PV equals to X. Open brackets here. 1 minus 1 plus I, the power negative n, then divided by I. Okay, we know the new loan now, that is 230, okay, 230, 100, okay, comma 56, we know the X, that's 5.5, 5,500, open brackets here, 1 minus 1 plus I, the rate is still 9%, okay, 9%, compounded monthly, so divided by 12, what is compounded monthly? Power negative n, we want to know how many payments this person must make, divided by this 9%, okay, 9% out of 12. So, let's find out here. Now multiply this one by denominator, divided by the 5,5. Okay, what do we get there? We're gonna say this money, okay, that is 230,100 together, 56 times denominator, which is 9%, 9% out of 12, okay, then divided by the installment, 5.5. Here it gives me this much here. 0,31377. I get what here? 0,3 0,3 0,313, okay, 77 equals to 1 minus, now what's in brackets here? Let's find out here. That is 1 plus 9%. 1 plus 9, what? 9% out of 12 gives us what here? 1,075. So 1,075, 1,0075 to the power negative n. So I'm gonna bring some bracket, make it positive, then I say 1 minus this, okay? So 1 minus 0,31377, it gives me here 0,68. So I'm gonna say that this one now it's the positive, gonna be this 1,0075, okay? Power negative n equals to 0,68 after subtracting from 1, 0,68, and again 6 to 3 here. Now we have exponential. To get our n, change it to logarithm, it's going to be negative n, logarithmic notation. Z, the base is the same, and it's going to be log base of 1,0075, okay? This number here, 0,68623. What's our n gonna be? Let's find out here with our calculator. So log base of 1,0075 of 0,68623 gives me negative 50,394. Negative 50, okay, comma 3 what? 394. Now if I divide by negative, gives my n equals to what? Equals to 50,394. Now the question was saying how many payments? How many what? How many payments? Now the full payments are going to be 50 with a smaller payment of this one here. So it means in total they're going to be how many? They're going to be 51 payments altogether. 51 payments must be done. 51 payments to be done to settle the loan. All right. Hope we are together. Let's go proceed here. Next question is here. What do we have? Question 8. Question 8. Using first principles, differentiate f(x) equals to 1 over x. Okay. What do we do here? Let's get some space. What do we do here? Now, when using first principles, we use the formula. And we only use first principles if the question says so. If they don't say so, please don't use it, waste your time. Okay, so here, now our f of x given is 1 over x. Okay, what about f of x plus h? It's gonna be what? F of x plus h. We're gonna put x plus h where there is x next. It's gonna be 1 over x plus h. Now the formula says that f derivative at x, okay, is given by the limit as h tends to 0 over f x plus h, okay, minus f of x, then divided by what? Divided by h. Okay, so in this case, my fx plus h is 1 over x plus h. So when I say that equals to limit, okay, as h tends to 0 over 1 over x plus h, okay, and then minus 1 over x, okay, then divided by what? Divided by h. So you can say times 1 over h. Okay, so in this case, now because I'm subtracting from here, it's like I'm gonna just multiply here, né? I'm gonna say equals to limit, okay, as h tends to 0 of this x comes here, okay, then minus this x here, minus h. Okay, divided by what? By x, open brackets, x plus h. Hope we are together. Then times 1 over h. Okay, so here I can see x minus x, it cancels out. So I'm left with now what? With the limit. I'm left with the limit as h tends to 0 of negative h, okay, over x into x plus h, then times 1 over h. Now this h is going to cancel this one here now. So now I'm left with negative 1 on top divided by x into x plus 0. Because they said limit h tends to 0, so it gives me negative 1 divided by x squared. That's our answer here. And I hope we are together. Okay, next question here. Now differentiate using rules. Okay. Now with rules of differentiation, we do like this then. Okay. We eliminate the brackets, okay, and then see what happens next. So if this is our y here, we can set our y. We're doing question 8.2.1. 8.2.1. Our y equals to down the brackets. Now the square root of 4 is 2. Okay. Square root of x power 6 is x power 3. So I'm going to say here x power 3. Okay. And then this is plus root 2 plus root 2, okay, times x squared. So now I can now differentiate. Now my derivative is going to be given by the y by the x, okay, equals to now difference is going to get 6 what here? You get 6 x squared, go together, then plus. Now here multiply by 2, that's 2 times root 2, okay, then subtract 1, becomes 1 here. And that's our answer there. Hope we are together. Then 8.2.2, to differentiate our g of x here, 8.2.2, we have to first split or divide by the same x squared everywhere to get the right g of x, which is split. So it's gonna be I can split by dividing 3x power 4 divided by what? Divided by x squared, okay. And then here I have minus 4x squared, okay, divided by x squared again, and splitting, then plus 6 divided by what? Divided by x squared. So here I'm gonna get 3x squared. I'm gonna say 4 minus 2. Now this x squared is gonna cancel this one here, so it's gonna be now minus 4 plus 6. Now the x squared, take it in, it becomes x power negative 2. From denominator becomes a negative power, so we can now differentiate my g of x. Okay, so the derivative equals to what now? Here we get 6 what? We get 6x minus 0. Then you're gonna say minus 12, okay, then x power negative 3. If they want it as a positive, no problem, you're gonna say 6x minus 12 divided by x cubed. That's our answer there. Okay, that was 8.2.2. Let us proceed here. They said now the equation of the tangent to f is on here. If x is 1, okay, the equation here, determine the values of b and c. So we need b and c. We need b and what? B and c. Okay, so now to get our b and c, because we know that a tangent is a line that touches the function at only one point, whereby both of them have the same gradient at that point. So we're going to find out what to do just now. Let me get some space here. So in this case now, They gave us what? They said that the equation of the tangent to the function f of x equals to 3x squared, okay? Then they say plus what? They say plus bx plus c at x equals to 1 is given by this equation, which is y equals 9x minus 9. So determine b and c. Okay, so in this case, my tangent is on here. This is my tangent here. And I know that the gradient m tangent here is what? It is 9. This 9 here. Now this other side, to get my gradient here, I differentiate. So f derivative x equals to what? Equals to 6x here altogether plus b. Now the gradient, if I put in x equals to 1, I must get this 9 here because it must be the same gradient. So I must say that f derivative at 1 equals to 6 times 1 plus b should give me the 9, which 9 is here. So what is 9 minus 6 to give us our b? Now 9 minus 6 gives us b at 3. Okay, after getting b, to get our c, because the same point lies on the tangent of the function, I'm gonna say that my f of x, that means f of 1, must give me the y value here when I put in 1, right? So it must be equal to the tangent to the y here. Okay, must be equal to the 9 times 1 minus 9. Okay, but my f of 1 here, I'm gonna say 3. Okay, open bracket, then 1 squared. Okay, plus b, which b I know now is 3. Okay, times 1. Then I'm looking for c, so plus c equals to 0. So 1 squared is 1 times 3. 3 plus 3, I get 6. So 6 plus c equals to 0. I get my c as negative 6. Okay, let us move on now. Next question here. It says that question 9. The graph of f of x equals to ax cubed d plus bx squared d plus cx minus 5 is drawn below. E, negative 1 is to 0, g 5 to 0, intercept of x intercept of f, so that a is 1, b negative 3, and c is negative 9 here. So what do I have? I think you guys can see that our function is turning along the x-axis. So this negative 1 is both a turning point and the x-intercept. So for that matter, it means that our function must be given by the equation y equals to a, open brackets, x plus 1 because of negative 1 here, x plus 1. We must keep a square here because this negative 1 is both a turning point and also the x-intercept. Then we say here x minus 5. Okay, x minus 5, x minus 5. Okay, so now to get my a, I'm going to use this point here. Now you see, because this negative 5 here, it means this must be negative 5 here, negative 5 here. Okay, so note when my x is 0, y is negative 5. No? So I'm going to say negative 5 here, negative 5 here, equals to a into 0 plus 1, okay, squared, then into 0 minus 5. So I'm going to get negative 5 here equals to negative 5a, equals to 5a. So which gives me my a as positive 1. After getting a, to get my b and c, I come and expand and open brackets here. I'm going to say my f of x, which is y, equals to a, which is 1, okay, into x minus 5, okay, x minus 5, into this one here, which is now x plus 1, okay, bracket squared. So I'm expanding now. I'm going to say y equals to x minus 5 into, what do you get here? we get x squared plus 2x, okay, plus 1. Okay, so now it's gonna give us x cubed here, okay, then plus 2x squared, right, plus 2x squared, then plus 1x, okay, plus 1x, then minus 5x squared, okay, and then minus 10x, what else, and then minus 5, okay. Now collect like terms here, we have x cubed here, so 2x minus 10x gives us what? Okay, 2 plus 1, that is 3. It'll give us minus what here? It'll give us minus 7, is it? Okay, what? Okay, square, we have here minus 5, minus 5x squared, okay, and then here the 2x plus 1x, that is 3. What? 3 minus 10 becomes minus 7, minus 7x, and then what about here? We have minus what? Minus 5, minus 5 here. So if we check here, let's check properly. Here. I beg your pardon. Now I beg your pardon here. I can see that this one's supposed to be squared here. Okay, properly. I can see that after multiplying this x times x squared, I must get what? X cubed. Then x times 2x, it gives me 2x squared. 2x squared, okay. Then x times 1, it gives me 1x, okay. Then negative 5 times x squared gives me minus 5x squared, Then negative 5 times 2 minus 10x, Then negative 5 times 1 minus 5. Okay, so what do I get here? I get x cubed, okay. Then 2x squared minus 5x gives me negative 3, so minus 3x squared. Then now x minus 10 gives minus 9x, okay, and then minus 5. So if you compare it with the given equation there, I can say that my a is 1, my b is negative 3 from here, and then my c is what? My c is negative 9. Yes, hope we are together. Then 9.2, calculate the value of x for which f has a local minimum value. Now local minimum value, we see here it's a turning point. What are we supposed to do? To differentiate and equate to 0, then solve for the x value. Okay. Right, so I know the negative 1 already. I need another one here now to get my what? To get my local minimum value. Okay, so I'm going to differentiate. Let's do like this now. Now that I have my function, okay, that is the question what? Let's check it here. 9.2. Now that I have the function, I'm going to say that's 9.2. 9.2. My f derivative must be equal to 0. So differentiate here. When I get 3 what? 3x squared, then minus 6x, okay, minus 6x here, and then minus 9 equals to 0 for the turning point. So divide through by 3. I'm left with x squared minus 2x minus 3 equals to 0. So it's going to give us xc minus 3 into xc plus 1 equals to 0. So it gives us either x equals to -1, which already we saw, or x equals to what? X equals to positive 3. What does the question want us to get? Okay. Must calculate what? The value of x for which f has a local minimum. So which means our answer here is what? Is x equal to 3. Because you see that that's the positive which is here. This is the local minimum here. And its x value here is going to be what? It's going to be the 3 which is here. So this is 3 here. Okay. Alright. What else do we need now? Let's check it out. They say here that use the graph to determine the value of x for which f second derivative times f of x is greater than 0. Use the graph to determine the values of x for which f derivative, second derivatives times fx is bigger than 0. In this particular case, I want you to note that if our function is of this shape which you see here given to us, then we know that its derivative is a parabola with a smiling face, and then that's the first derivative. Then the second derivative is a straight line with a positive gradient. That's from our theory. And don't forget that in that particular case again, when we have this function here, our turning point the same as the x-intercept for that parabola in question. So what am I talking about here? Pay attention here. So in other words, I'm looking for where I'm going to get the product bigger than 0. So I'm going to look for where the second derivative is either positive times positive to give me positive here, or negative times negative to give me a positive here. So here we go. Now I'm saying that if this is the shape for the cubic function, so the parabola, okay, but then let's first differentiate again. First differentiate this again. We know our a, b, and c. Okay, so if I check it here properly, my first derivative, okay, my f of x, first of all, f of x equals to a, which is 1, x cubed, okay, x cubed, then plus what? B is minus 3x squared, so minus 3 x squared. What about B? What about C? Minus 9x, okay, minus 9x, and then minus 5, okay. Now our first derivative, this one here, given by 3x squared, okay, 3x squared minus 6x, then minus 9. What about second derivative, which we're looking for? This one here, given by 6x minus 6. Okay. Now these functions, they have got a relationship. Okay. Now this one, which is the first derivative, it is a parabola, whereby the intercept c. And by the way, to get our x for the point of inflection, it just equal to 0, equal to 0 here. So I see that here my 6x equals to 6, giving me my x for the point of inflection as what? As 6 over 6, which is 1. Okay. So meaning somewhere around 1 here, because there's a 2 and then 1. Around 1 here is going to be my what? My x for the point of inflection is equal to 1. Now, note that if I draw for you this in red, the parabola, it must be passing through the turning point like this, the intersection, like this, and then it's going to turn, have a turning point here, which is the same as this with the same x value here. Okay, then but passing through the intercept, which is the x for the turning point here, all together. That's the shape there. And then because I'm talking about now the one which is a second derivative, it is gonna be from here, okay, passing through this point here, which is because if we check here, it is y equals to 6x minus what? Minus 6. When I put in x equals to 1, when x is 1, it's gonna be 6 1 minus 6, which gives me 0, ne? So it must be passing through this point here, okay? And then what about when I put x equals to 0? I'm passing through a 6 somewhere here, a 6 down here. So mean that if this is negative 5, and then this is another point here. So to draw my second derivative, I just draw it passing through a 6, okay? But having a positive gradient, ne? Let me use a blue color now here. So it goes like this. What? Having a positive gradient. Okay. Yeah. Passing there like that. Okay. Now the question says here that this is my function f of x. This is my first derivative, okay. This is my second derivative here. So the question says that which x values, when you multiply f of x times f of x, is going to be bigger than 0. That happens when either both of them are positive, because a positive times a positive, okay, it will be bigger than 0. So where are they positive? Now I can see that from this point 1 going this way, the function is below, okay. That means they are all negative, ne? That's another alternative whereby they're all what? All negative, because I know I will get also positive in this case. So my first answer, because they're all negative here apart from negative 1, it means that it's going to be x, okay, less than 1, except at negative 1 here. Why? Because at negative 1 it will give us a 0, but we don't want 0, ne? We want bigger than 0. Okay, then now for this other side here, if I go beyond 1, from 1 to 5, I see that this one is got negative y values. This is positive, so I don't want this. But beyond 5, I see f is going to be positive. Also, the second derivative also positive, which means it's going to be now x greater than 5. So those are the answers which we need here for question 9. Point what? For 9.3. Okay. Then 9.4, they say, for which values of t will the graph p of x equals to fx plus t have two distinct positive real roots and one negative root? So now the roots, we determine them by using this line here. Okay, let me clean up this now. Okay. Now check this out, guys. The roots, we get them like this. If I draw a line, okay, now from here, from the x-axis, from the x-axis, we have only two roots. Why? That's where we say that the function is touching the x at only 2 points. Touching here, this is one root, another root is here. Now to get other roots, we can have another line like this. Check this out, guys. If I draw it here, for example, from here, but it must be what? Must be parallel to the x-axis. So you see here, now here between 0 and negative 5, I see that my function is the line is touching the function at this point here, and another point here, okay, and another point here. Because these are 3 points, let me call them yeah, this point A here, point B, and point C here. So this one give me 3 roots, there is this one here, which is my root x1, okay, another root here, my root x2, and here another root x what, my root x3. But the question wants them to be only two distinct positive and one negative. Now when can they be two positive and one negative? Check here now, guys. If I draw a line like this now, check, like this from here up here, which is part of the x-axis. Now I can see we are cutting here at this point here. This one will give us one root here altogether, which is going to be negative, right? Because it is less than 0. This will give us a positive root here, okay, and then also another positive root here, all together. Then if I continue until this turning point here, I can see there that from the turning point, I can see that here now I'm only touching the curve only twice, right? Meaning I only have 2 roots, but I want 2 roots. I want 3. I want 2 positive and 1 negative, which means that my t, this t here must be y value. It's going to be between this value here, the y at this point here, and then the negative 5, because with negative 5 below this one here, I have the 2 positive and the 1 negative. So let me first find out this one here, the y for this point by using this 3, okay? So I'm going to find f of 3. So if I find f of 3, what is it going to be? Let's put it in here. In our function, we are putting in f of 3. What do we get here? Check it out here. This was the function, don't forget. We are putting in 3 here to see the y value there. So we're going to say, open bracket 3 cubed, okay? Then minus 3, open bracket 3 squared, okay? Minus 9, open bracket 3, then minus 5. It gives me negative 32. So here I have negative 32. So this negative 32 here, negative 32, negative 32. So my answer is going to be from negative 32 up to negative 5. That's my answer. So my t must be between what? Between negative 32 from down there, but not bigger than what? Not bigger than negative 5. That's our answer, which is 9.1 for 9.4. Okay, next question here. Let's find out now. They say here, question 10, that EHGF is a rectangle. HE is produced x squared centimeters and to N, and the EH is produced x squared centimeters to P. NF produced intersects PG produced at M to form an isosceles triangle MNP with NM equals to MP. D lies on NP, where MD is what? Perpendicular to NP, and the NP is 4 centimeters and the MD is 3 centimeters. Okay, so what do we need? Let me make it a little bit bigger. Okay, they say here that they say that on 3, and then they say this isosceles triangle. Okay, this one is being perpendicular. Now what are we supposed to show? So that the area, this area which is shaded here, is given by this one here. So how do we find area? Area equals to length times breadth. Now the length for this one is going to be from E to H. That be E to H, or you can call it HE, times this B which they gave us here. Now the HE, this is, you see this is x squared, this is x squared here. The whole of this one is 4. So from E to H is going to be 4 minus 2x squared. It's going to be what? 4 minus 2x squared. Okay. Then times B. Now how do we find our B? Let's find out now. In this particular case, because this is a rectangle, this must be 90 degrees. Also here 90 degrees given to us. So these lines are parallel. They are what? They are parallel. And then they say this one is 4 altogether. And they say this one is what? This one is 3. This is 3. Okay. So this one being a 4, this one being in the middle, it means we divide by 2. So 4 divided by 2, that means from here up to here, it is what? It is 2. Right? It is 2. And then what about from D up to M? They say it is 3. That's MD. It is 3 here. That is 3. So if I consider these triangles here, triangle here like this, okay, and then this one here like this. What about that? From here up to here, okay, and then from here up to here, and then another small triangle which I'm going to put in red now. From here up to here, Also from here up to here, from here up to here. Okay, so now I want to get my B because I need B here to get my answers. Now I'm going to use what we call as the proportionality theorem. I can say that B divided by 3 equals to x squared divided by 2. I can say what? I can say B divided by this is 3, which is mn. Okay, divided by 3 equals to this x squared. Okay, x squared divided by what? Divided by from n to d, which is 2, divided by 2. So in this case, my b equals to x squared times what? Times 3 over 2. So I come back and substitute now to get my area in terms of x. So my area in terms of x equals to b, which is what? Which is 3, x squared over 2, okay, times open brackets, which is 4 minus 2x squared. Okay, what do I get here? I'm going to get, open brackets here, the 2 is going to cancel here to give me 6. I'm going to get 6 what? I'm going to get 6x squared, okay, then minus what here? The 2's are going to cancel, minus 3x power 4. Minus 3x power 4. That's our area in terms of x as required. Hope we are together. Next question here. Let's now calculate the what? Calculate the maximum area of rectangle EFGH. That is EFGH. Okay. Now, guys, we never talk about maximum area, minimum. We differentiate the given expression, then equal to 0, and substitute. Okay. Now, this one here is our area here. So, let us now differentiate that. That's question 10.1, 10.2. Okay. 10.2. You're going to differentiate. Ne? What do we get here? We get 12 what? 12x, okay, then minus again 12 what? 12x power 3, but it must be equated to 0 because of this word what? The word maximum. So what is common here? What's common here is 12x, right? So 12x left with 1 minus what? Minus x squared equals to 0. Now because of the 0, it means either x equals to 0 or the bracket, which is 1 minus x squared equals to 0. So here I get either x equals to 0 or x equals to 1 or x equals to -1. Okay. So now if I check here now, if I use a 0, now this is my area for my expression for the area, which is area in terms of x, is given by this, that is 6 what? 6x squared, okay, minus 3x power 4. So if I put 0 here, I'm going to get 0 area. That can't be the maximum, okay? If I put 0, okay. Then if I put 1, because all these powers, they're even powers, I'm going to get the same as -1. So if I put a x as 1, what do I get here? I'm going to get 6, okay? Then 1 squared, and then minus 3, then 1 power 4, okay? So it gives me what? It gives me my area as 3 units squared. Number 3 what? 3 units squared. So my maximum area here is what? Is 3 units squared. 3 units squared. That's our answer here. I hope we are together. Our last question for this paper, 2024 May June. They said that two events A and B are such that probability of A is 0,4, A or B is 0,52, A and B are mutually exclusive. Now, one probability of B. Now, what do we know about events which are mutually exclusive? Their intersection is 0. Now, don't forget that with probabilities, generally, probability of A or B is given by what? Probability of A or B is given by what, guys? Probability of A or B, that's the same as union, is given by probability of A, okay, plus what? Plus probability of B minus the intersection, minus the intersection B, okay? But then in this case, because of the word mutually exclusive, intersection here is 0, okay? Let's now substitute here. The A or B is 0.52, so 0.52 here, okay? Probability of A 0.4, 0.4. Looking for what? Probability of B, okay? So we're gonna see that our probability of B equals to what? Equals 0.52 minus what? Minus 0.4. So what do we get here? We're going to get 0.12, 0.12 as our answer here. That's probability of B, okay? Hope we are together. Why? Because if they're mutually exclusive, intersection is 0. If they had said that they are independent, then our intersection would have been what? The product of A and B. Hope we are together. Then they say question here that the items that Elena bought at the tax shop were recorded over a period of time. Probabilities of Elena buying a sandwich: S, chocolate; C, juice; J, as shown in the diagram below. In the diagram here, what's the probability that Elena will buy a sandwich? Now, to buy a sandwich here, we look at the probabilities on all the circles for the sandwich here, okay? So which ones are they? The circle for sandwich is from here. So we're gonna add all the probabilities in that circle. Okay, what do we have, guys? We're gonna say 0.02, okay, plus 0.01 plus 0.04 plus 0.09. What do you get? 8 for me. 0.02 plus 0.01 plus 0.09 plus 0.04. What do you get, calculators? Here I get 0.16. I get what? I get 0.16. So here, this is 0.16. After adding everything here, 0.16. Okay, 0.16. Next question, she says that calculate probability that Delena will buy at least 2 of the 3 items. Now, if we say at least 2, we mean 2 and more. We mean what? 2 and more. So where do we have this Lena getting 2? We have this 0.03. We put it in red now. Okay. 2 or more. We have got 0.03, this one here, 0.04, this one here, 0.02 all together, and the all more means 0.01. So please, can you add them? What's your answer here? Here I am getting 0.1. 0.1. Hope we are together. Next here, what do we do next? Next, they say here that we should now do what? Probability that Elena would not buy any of the 3 items. Would not buy any of the 3 items. Now, if you don't buy any of the 3, it means you're outside the circle. So what do we do here? We're gonna say 1 minus total probability, because you're not in the circle. So in that case, you're gonna add everything in there and subtract from 1. So you're gonna say here it's gonna be now 1. Okay, it's gonna be 1 minus the total. So if you add everything here, I'm getting what? I'm getting 0.43. When you add everything in here, 0.43. So from 1, which gives me which answer here? Which gives me here 0.57. 0.57 is my answer here. Then lastly, our last question here, which is so interesting, from the counting principle. Let's check it out here. They say that 7 guitar players, each with a different name, participate in a concert. In how many different ways can the names be of the guitar players be seated one below the other in the program? Okay, so how many are they? They are 7 guitar players. Okay, because there are only 7, they can be seated in 7 factorial ways. So here it's gonna be what? 7 factorial, because they can be seated anyhow. Okay, so what is 7 factorial? Calculator, what do you get? From my calc here, 7 factorial, it gives me 5040. It gives me what? 5040. 5040. Then this, after the performance, the guitar players wait backstage. There is a bench with only room for 4 to sit on. What will be the probability that the 4 guitar players will be sitting in alphabetical order from left to right? Okay, so now these players, they are 7, but the seats which we have are only 4. So if I may do like this, okay, you may say that if this is the first seat here, another seat here, another seat here, and another seat here. Now, how many players are they all together? They are total, which means in the first seat, any of the 7 can sit here. 7 minus 1, any of the 6 can sit here. Then any of the remaining 5 can sit here. Any of the remaining 4 can sit here. The seats are finished. So my answer here is going to be 7 times what? 7 times 6 times 5 times 4. Then divide by the total available space, which is 5040. So what do you get here? I'm going to get what here? Anybody with a calculator? I'm going to get here. This is 840. Okay, 840 divided by the total, which is 5040. So simplifying this one here, what do you get? Calculators there. Here I get 1 over 6. I get 1 over 6. Okay. Then lastly, they say here that during the performance, the 7 guitar players sit in a line on a stage. 4 guitar players are female and 3 are male. In how many different ways can they be seated if the males may not sit next to each other? Okay, I repeat, during the performance, the 7 guitar players sit in a line on stage. 4 guitar players are female. That means there are how many females? 4 females, okay. And then they say the 3 are males. So we have got 3 male guitar players here. They say in how many different ways can they be seated if the males may not sit next to each other? May not sit next to each other. Now, because of this may not sit next to each other, we do it in the opposite way. Let us find out if the males were sitting next to each other. Then we're going to say 1 minus that answer. So I'm going to say 1 minus if the male. Yes, hello. What if the males sit next to each other? Now we have the 4 females and then the 3 males. Now if the males are 3, it means they can change, they can sit anyhow in 3 factorial ways. Then the group of the males, okay, together with the 4 females, it makes what? It makes the 5. Okay, that brings us to 5 factorial here. So we're gonna have, remember this is the total, which was 5040, minus here the males sitting next to each other. So you're going to say that it's going to be giving us what? 50, okay, 5040. Then minus this answer here. What do you get here? Calculators. What do we get here? What is 3 factorial? 3 factorial multiplied by 5 factorial. It gives us 720. So minus 720. Minus 720. So our final answer is going to be here. It's going to be the 5040 minus what? Minus 720, which gives us here 4320. Gives us 4320. 4320. Yeah, these are the ways whereby the males will not sit next to each other. Yeah, thank you so much for watching. Catch you again in our next video. My name again is Patrick Kamala. I'm a tutor educator with and science here by Roster College Polokwane. Thank you so much for watching. You can subscribe to our channel to get more notifications, including our live sessions. Bye bye.